So, now I'm going to be talking about a couple of things related to, like, Earth, its geology, and a somewhat related topic in the next video called crater dating. So, let's start with the Earth. So I'm going to talk about the Earth's overall structure. I'm going to draw like a cross-section of the Earth. So if I'm looking at a cross-section of the Earth, you've got this pretty thin outer layer. That's the crust. That's what we're all standing on. You know, it's rock. Very thick, but thin relative to the overall size of the Earth. Focus the videos on there. Then, within the crust, we next have the mantle. This is made up of magma, which is lava that is still inside the Earth and not up on the surface. Molten rock, basically. And then, inside the mantle, you have the core, which has an outer core and an inner core. And the outer core and inner core are made up of metal. Some of it's molten because of how hot it is, and some of it is solid because even though it is easily hot enough to be molten, it's under so much pressure that the pressure makes it a solid anyway. So this is like the basic structure of the Earth, but there's actually one kind of unique trait of the Earth is that the crust is not actually one thing. The crust is composed of a lot of different plates, which aren't connected to each other and can kind of float around on the mantle freely and independently of each other. These are called tectonic plates. And over time they move. They move very slowly, but definitely very appreciably over time, and that causes a lot of interesting stuff to happen. For one thing, you may have seen like a documentary about dinosaurs or something, and it might have shown something like, this is what the Earth looked like in the time of the dinosaurs. And it's like the continents are all different. That's because of tectonic plates. The continents move over time. You may have noticed that it kind of looks like South America and Africa fit together. Like Africa has that curve on its eastern side, and South America has like a big point. Africa has a curve on its western side, and then South America has that big point on its eastern side, and it kind of looks like they fit together. They used to fit together, right? They used to be next to each other, but they split apart because of continental drift, which is caused by tectonic plates. Now, another thing that's interesting about tectonic plates is that they can run into each other, right? Because they're all next to each other and they're all moving around in their own ways, and so sometimes they're going to run into each other, and that causes some interesting things to happen. So there are three main things that can happen when two tectonic plates run into each other. I'm going to draw them. Maybe I'll draw them. Maybe I'll just show them with my hands. We'll see. So, here we've got, here's one tectonic plate, and here's another tectonic plate. This one's a little shorter. I'll make it longer. And they're moving. They're about to hit each other. There are a few things that can happen. in this situation. In one situation, when they hit, one kind of gets pushed under the other one. Something like this. And it's pushed into what is below the tectonic plates, which is the mantle. That's what they're sort of floating around on. This is called subduction. And one of the things that happens with subduction is that the part of the crust of this plate that's getting pushed into the mantle gets melted because the mantle's really hot and it turns into more of the mantle. Meanwhile, you can think of the other side of this plate, there's like space opening up here. So some mantle's going to come up and cool off and turn into new crust on this side. So through subduction, you kind of have this process of crust material getting recycled over time, changing places with material from the mantle. Another thing that can happen when the two plates run into each other is that upon hitting each other, they kind of push each other up. Like scrunch each other up, like, it's kind of hard to draw, but something like this. Right? This is what forms mountains. It's also what forms volcanoes. Volcanoes are just a type of mountain. The only difference between a mountain and a volcano is this. So here's like a volcano. In a volcano, because as you now know, mountains and volcanoes are situated over where two plates have hit each other. And so under those plates is the mantle, and then there's a space between them. Volcanoes form in such a way that there's a little tube coming up from, the mantle down here, up through the mountain where the two plates crashed into each other. And so lava can come up through the tube in a volcanic eruption and get out onto the surface. Mountains are just the same, except they don't have the tube. Or maybe they have the tube up part of the way, but it doesn't get to the top. It's blocked off. So normal mountains can't erupt. But fundamentally, there's not a whole lot of difference between mountains and volcanoes in this sense. And it's this that causes both of them, tectonic plates pushing each other up. The last important thing about the last major tectonic plate interaction is maybe they hit each other and it seems like they're not really doing anything, but they're still pressing on each other. And as this is happening, these two things are very massive, and they're both kind of pushing into each other, and it creates a tremendous amount of tension. Right? Like two people pushing on each other, or, someone pulling really hard on a rope. But then eventually, something's going to give. And when the tension breaks, it's going to cause a very quick and very dramatic shift from all that tension that was built up suddenly, breaking. Like, you're pulling really hard on a rope, and then the thing it's attached to gives way and you just fly back. This is what causes earthquakes. This is like why California gets earthquakes so much. It's on the border between two tectonic plates, so it gets a lot of earthquakes. That's also why it has mountains. It's why mountains generally form in ranges. You don't have just individual mountains just anywhere, right? They're all together, and that's because mountains form along the boundaries where two tectonic plates hit each other. I'll probably write down how you spell tectonic. It's like this. Alright. So I think that about covers tectonic plates. Next time I'll be talking about crater dating.